So, what is prime factorization? Well, let's break it down just by the words that we already know. We know what prime numbers are. They're numbers that have two distinct factors, one and themselves, or one distinct area model. They're not composite, they don't have multiple factor pairs, just one pair of factors that are two distinct numbers. And wait, we already know what factor means. It's a number that you can multiply together with another factor to equal the answer, to have a product of the number that you're looking at. So for example, a factor of 10 might be 2 because you can multiply 2 times another factor, 5, to have a product of 10. Okay, so we're only not clear about part of this word. But I think prime factorization, based on this, is going to have something to do with factors that are prime. Let's try it. Prime factorization, factors, or when you multiply factors together, this right here is prime factorization because each of the factors is a prime number. It is the prime factorization of 30, which is not a prime number. But that's okay because the prime factorization is what we're looking at. Now, when I ask you to find me the prime factorization, just like when I asked you to find me the factors, we have some helpful drawings that can help us find all of the prime factors. So let's pick a different number other than 30. I'm going to pick something a little bigger. Let's go with 50. Now, I can either have a prime number or a composite number, but if it's already prime, then the prime factorization is just 1 times itself. So I would never ask you to find the prime factorization of a prime number. They would always be composite numbers that you're going to find the prime factorization of. And to do that, we're going to make something called a factor tree. Different from a factor rainbow, but still kind of the same idea. In a factor tree, I'm going to find 2 factors of 50. It doesn't matter which factor pair you pick. You just have to pick 2 factors that can multiply together to 50. And everyone can do this differently, so sometimes factor trees look different. But I'm going to pick 5 and 10 because 5 times 10 equals 50. Now I'm going to look. Are either of these numbers prime numbers? Ooh, 5 is. So I'm going to circle it because I cannot break that down anymore into different prime numbers. Because if I actually tried to break this down and said, oh, that's 1 and 5, and that's 1 and 5, it would never end, right? I would just keep going and keep saying the same ones. So once I hit a prime number, I stop and I circle it so that I know that that's part of my prime factorization. But 10 is not a prime number. It's composite, so I can keep breaking it down. Let's see. What's a factor pair of 10? Oh, 2 and 5. Because 2 times 5 equals 10. 2 is a prime number, so I circle it. 5 is also a prime number, so I circle it. And at this point, all of those branches of my trees have ended in prime numbers. We can think of the prime numbers as the leaves of the tree, and it's all leaves, so I'm done. But my prime factor tree is not my answer. So when I list my prime factorization, I'm going to go from least to greatest. And I'm going to say that the prime factorization of 50 is 2. Cross it off as I write it just to help me keep track. Times 5 times 5. If I multiplied that back together, I would get a product of 50, which is always a good way to check. Now, this is my prime factorization in expanded form. Most often you would see your prime factorization in exponential form, which means that I would look, oh wait, these two? I can write that as an exponent. So I would say that the prime factorization of 50 is 2 times 5 to the power of 2. Because 5 to the power of 2 actually means 5 times 5. So this is my prime factorization written with exponents. Let's try another one. The prime factorization of 120. Break it down. I always like, if it ends in a 0, just to break it down into a factor of 10 and whatever the remaining factor would be, because 12 times 10 does equal 120. All right, these are both composite numbers, so I keep going. 2 times 6 also equals 12. 2 is a composite number, like one of my leaves on my branches. 2 is prime. 6 is composite, so I keep breaking it down into 2 times 3, which are both prime numbers. But wait, don't stop there. We have to go back and look at 10. 10 is also composite, so I break it down into 2 and 5. 2 is prime number, 5 is a prime number. Now that every single branch has ended in leaves, I'm done with my factor tree, but not with my prime factorization. Let's see. In expanded form, I have, starting with the smallest number there, 2 times 2 times, I'm not going to write that 3 yet because there's another 2 and 2 is still smaller than 3. 2 times 3 times 5. This is my expanded form. Watch out when you read a question asking you for the prime factorization. You might see it this way, or you might see it as 2 to the power of 3 because I've repeated the factor 2 3 times, times 3 times 5. These are both correct, just depending on what the question was asking for you to give them, you might have to pick one over the other. I'll give you one more example, and then we'll call it a day on prime factorization and factor trees. Let's say you have a question that says, which of the following is the prime factorization of 50? You have two choices when you're solving a problem like this. Number one is you can go off to the side and say, ooh, factor tree of 50. 5 times 10. 5 is a prime number. 10 is composite, so I keep breaking it down. 2 times 5. Prime number. 2 times 5 times 5. I don't see that anywhere, but ooh, wait, I do see 2 times 5 squared, or 5 to the power of 2, which is the same thing. So that's my answer. That's one way to do it. Or you can multiply out each of your answer choices. 2 times 25 is 50. 2 times 3 is 6. Times 5 is 30. 2 times 5 to the power of 2 is 2 times 5 times 5. 2 times 5 is 10. Times 5 is 50. 3 times, what's this? 5 times 5 is 25. Times 3 is 75. Wait a minute. I have two possible answers that could be 50. Right away, you can eliminate and be like, no, 30 is not the same thing as 50. That's not going to be my answer. 75 is not the same thing as 50. Not going to be my answer. Oh my goodness gracious, what do you do? Two possible answers of 50. I did it this way first. I thought I had the answer over here, but now this one over here, A, looks like it could also be my answer. Pause. The question is asking you for the prime factorization. Not any old factorization of prime and composite. The prime factorization. Is 25 a prime number? Is its only factor pair 1 and 25? No. Because you know that 5 times 5 is 25. Therefore, 25 is composite, not prime. And even though 2 times 25 does in fact equal 50, this is not the prime factorization of 50. That's just factorization. It's two factors of 50, but not the prime factorization. So C would be your final answer. Now watch out, because A would be like the trick answer. You'd be like, oh yeah, 2 times 25, I totally know that's 50. Make sure that you are really thinking through the question and what it's asking you, because that will most likely appear as a trick option for any prime factorization question. And that's what you need to know about prime factorization and prime factor trees.